Hello there, and welcome to Forgotten Worlds. My name is Thomas, and tonight I'd like to invite you into a quiet place of wonder, a place where questions move more slowly than answers, where science and imagination share the same breath. Settle yourself in, let the noise of the day fade, and picture this with me. It's July of 2025. Astronomers scanning the night sky in Chile with NASA's ATLAS survey catch sight of something faint but unusual. A point of light, about 670 million kilometers away, carrying with it the soft blur of a coma, the hazy veil of gas and dust that tells us we are looking at a comet. But this one is different. Its path is no lazy ellipse around the sun. Its orbit is hyperbolic, sharp, impossible to bind. Its speed is astonishing, 58 kilometers every second, racing past the sun with no intention of ever returning. They name it 3IATLAS, the third confirmed interstellar visitor in human history. First, there was Oumuamua in 2017, then Borisov in 2019, and now this, a wanderer from beyond the solar system. A traveler that has crossed billions of years of darkness to brush past our small world before disappearing again into the stars. And yet, as we watch its path, another thought lingers. What if it is more than frozen gas and ancient dust? What if 3IATLAS carries with it not only matter, but memory? Not only the fingerprints of stars older than our sun, but perhaps even whispers from a universe that came before ours. That is our question tonight. Not a debate, but an exploration. Not a theory to prove, but a thought to dwell on. What if this faint, fragile fragment holds secrets from a forgotten universe, a cosmos erased, leaving behind only this drifting shard? Take a deep breath with me. Imagine that glow against the blackness. Imagine its long, lonely journey. Tonight, we will follow it, step by step, through the moment of its discovery, the strangeness of its orbit, the mysteries of its chemistry, and the possibilities it stirs in both science and story. And always, lingering in the background, the soft, unsettling question: is 3IATLAS only a comet, or is it something more? The story begins not with fireworks or cosmic drama, but with a flicker of light barely strong enough to register on a digital sensor. In the high desert of Chile, at the Rio Hurtado Observatory, the Asteroid Terrestrial Impact Last Alert System, ATLAS, was quietly performing its nightly duty. It is a survey built for vigilance, not glamour, designed to protect us by scanning the heavens for objects that might, one day, cross Earth's orbit in dangerous ways. Its telescopes sweep the skies in wide, patient arcs, mapping the shifting points of light against the unblinking canvas of stars. On the first evening of July 2025, the system flagged something new. At first glance, it was nothing unusual, just another moving dot in a sky that hides countless wanderers. But as the data settled, astronomers noticed something odd. The light wasn't sharp. It was fuzzy, surrounded by the faintest glow. Even at a distance of more than 4.5 astronomical units, 670 million kilometers, it was already wearing a halo, a coma, a veil of gas and dust streaming from a solid heart. That alone set it apart. Most comets sleep until they draw much closer to the sun, their surfaces locked in ice until solar heat wakes them. But this object seemed restless, releasing vapor far earlier than expected, as if carrying ices too volatile to stay bound even in the chill beyond Jupiter. Its brightness shimmered at magnitude 18, faint to the naked eye but distinct through careful instruments. And behind that shimmer, an ancient story was waiting to be told. From Chile, word spread quickly. The data was sent to the International Astronomical Union's Minor Planet Center, and astronomers around the world began to turn their eyes toward Sagittarius, where the object traced its hidden path across the crowded starfield. The galactic plane made for difficult viewing, stars layered thick as sand grains on glass, but even there, the traveler's glow could not be mistaken. Soon, researchers searched old archives for its trail, and there it was, faint but real, in images taken weeks before, even months. Photographs that had captured its light unknowingly, like memories tucked into the margins of a notebook. With each recovered frame, its motion became clearer, its orbit could be sketched, its future could be glimpsed, and the more the path revealed itself, the more astonishing it became. This was no member of the Oort cloud, no slow drifter shaken from its icy shell. Its orbit was not elliptical, not parabolic. It was hyperbolic, an open curve, never to close, never to return. The eccentricity was extreme, greater than 6, far beyond anything the sun's gravity could hold. Its velocity was equally telling, nearly 60 kilometers every second, more than twice the speed of the fastest long-period comets. This was an outsider, a stranger, an interstellar visitor. By July 20, confirmation was official. The Minor Planet Center announced that the object was not bound to the Sun. It was catalogued as C 2025 3IATLAS, but more evocatively, it was given the prefix 3I, the third interstellar object known to humanity, after 1I, Oumuamua, in 2017, and 2I, Borisov, in 2019. A rare addition to a family of wanderers that may number in the trillions across the galaxy, but that only rarely drift close enough for us to see. And here, beneath the science, another thought rises. Imagine standing under that Chilean sky the night the signal first appeared. The air is cold, the desert quiet, the telescopes whirring in slow arcs above you. On your screen, a faint point begins to shift against the background. You lean closer. It flickers, carries a halo. It is small, fragile, ancient, and yet somehow it has chosen this moment, of all moments, to appear. Perhaps that is only coincidence, the meeting of chance and patient observation. But what if it is more? What if the timing of its discovery was not an accident, but a rhythm? A kind of cosmic tide that pulled this fragment into our sight at the precise instant we had the tools to notice. Not a message in the deliberate sense, but a convergence of circumstance, a moment when the universe allowed a hidden story to be glimpsed. It raises a strange intimacy, that out of all the nights of the cosmos, all the centuries when such objects passed unseen, this one revealed itself now to us, here, in our brief age, a shard from beyond the sun, appearing not in myth or prophecy, but in data streams and telescope images. And still, the question lingers. What if this faint flicker was meant to be seen, meant to remind us that even the darkest spaces are not empty, but full of wanderers carrying forgotten histories? Take a moment. Imagine yourself as one of those astronomers. The room is lit only by screens. The stars outside are so numerous they seem to press against the atmosphere itself. And there, among them, a small messenger begins its story. Not loud, not obvious, but steady, insistent, impossible to ignore. The first thing astronomers noticed, once the orbit was mapped with confidence, was that this object had no intention of staying. Its path was not just wide, not just long, but utterly unbound. The eccentricity, a measure of how stretched an orbit is, told the story. Where a circle measures at 0 and an ellipse stays below 1, this comet soared beyond 6, a value of 6.14, staggering, impossible for anything born in the gravitational nest of the Sun. This number alone declared its origin, not from our system, not from the Oort cloud, not from any distant belt of icy fragments. It had come from elsewhere, from far beyond the solar frontier. And then there was its inclination, nearly 175 degrees, retrograde. Instead of flowing in the general direction of the planets, sweeping around the Sun in the same cosmic dance that carries Earth, Jupiter, Saturn, and all the rest. It moved against the current. Imagine a river where every drop of water rushes downstream, and then suddenly, one fragment of ice floats upstream, indifferent to the pull. That was 3IATLAS, a rebel against the patterns that define our familiar skies. In this, its nature was made plain. It was a visitor, yes, but also a fleeting one. The curve of its orbit would bend as it brushed the Sun, but the bend would never close. Once past, it would climb outward again, sliding back into the interstellar dark, leaving behind only faint dust and data. Humanity was offered a single chance to see it, a single moment in an unthinkable timeline. Picture it this way. Imagine standing at the side of a vast road that stretches without beginning and without end. Along it, countless travelers hurry past, most too far or too faint to notice. Then, just once, one of them wanders close enough to cross your line of sight. For a heartbeat, you glimpse them. You see their face, their scars, the story written in their eyes. And then they vanish again into the distance, never to pass that way twice. That was 3IATLAS, a cosmic passerby, a courier from far away whose route intersected ours by chance, or perhaps by design, for only this single crossing. And here, in the quiet of night, speculation opens its hand. What if this was not just a matter of random geometry? What if its arrival was part of some larger pattern, one invisible to us, but inscribed in the deeper fabric of time? Its orbit is unrepeatable, its path untraceable back to any home star we can name. It emerges from the void and returns to it, almost as though it were meant to remain anonymous, a messenger without a signature. Some have said that comets are like letters in bottles, tossed into the cosmic sea. Most never find a shore. Most drift until they crumble into silence. But this one washed upon our beach, glowing faintly in the starlight, and then continued its journey. The contents of its message, if it carries one, remain uncertain. Was it no more than a note from a forgotten star system, a record of chemistry and ice? Or was it something deeper, a fragment from a universe that existed before ours, slipping through the seams of cosmic rebirth? Against the backdrop of all this speculation, the fact remains. 3IATLAS will not return. Its hyperbolic excess velocity guarantees it. No gravity well in our solar system is strong enough to pull it back. Not even Jupiter, mighty as it is, could slow its passage. It came, it was seen, and it will leave. And there is something almost haunting in that finality, a feeling that we were allowed only a glimpse, a single meeting, like crossing paths with a stranger whose life is larger than our imagination, whose story continues far beyond our horizon. We might never know its origins, never know the details of the systems it passed, never know if it once circled a star or drifted free from the beginning. All we have is this encounter, this fragile chance to listen as it whispers past. Imagine watching it through a telescope, night after night, its glow shrinking as it climbs higher from the sun. Each evening, it is a little fainter, a little more remote. You know, with each passing night, that you are watching it slip away, that the moment of communion is closing. And yet, even as it fades, the wonder grows. For its very departure, its refusal to linger, is what makes it so extraordinary. Because what if that is the message itself? That not all things stay, that some stories pass through only once, offering us not permanence, but memory. 3IATLAS, with its impossible orbit and its retrograde defiance, may be nothing more than ice and dust. Or it may be something greater, a courier from beyond, carrying in its silence the reminder that the universe is full of messengers, and that not all of them will wait for us to catch up. If its orbit spoke of origins beyond the sun, its speed declared it even louder. From the moment its path was measured, astronomers knew they were dealing with something extraordinary, 58 kilometers every second. Try to hold that number in your mind. It means that in the time it takes you to breathe in and breathe out, this fragment of ancient ice has traveled farther than the distance between two cities. In 1 minute, it could cross the span of the Earth itself. Most comets that belong to our solar system move swiftly, yes, but within bounds set by the sun's gravity. Long-period comets may arrive from the distant Oort cloud at a few tens of kilometers per second, their journeys dictated by ancient perturbations. But this speed, this excess velocity was different. It could not be explained by any gravitational push from within our system. It was the mark of an object hardened and flung across space by forces far older, far larger than anything our planets could provide. To reach us at such velocity, 3IATLAS must have been shaped by a lifetime of encounters. Perhaps billions of years ago, it formed quietly in the outskirts of some distant star system, orbiting in the cold and forgotten reaches where light was faint and shadows permanent. And then something shifted. A gravitational nudge from a wandering planet, or the collapse of its home system, sent it outward. From there, it began a journey of scattering past suns, through the long arms of the galaxy, slingshotted again and again by stellar encounters. Each pass stealing or gifting momentum until the comet carried within it the memory of billions of years of stellar gravitation. The number itself, 58 kilometers per second, is only a measure, but if you close your eyes, it becomes a feeling. Imagine standing on a high cliff above the ocean, and a storm wind rises so fast you cannot hold your balance. Imagine a river not just flowing, but tearing past, carrying trees, boulders, whole landscapes with it. That is the energy of such speed. Not chaotic, not destructive in this context, but relentless. A motion so enduring it seems less like travel and more like destiny. And here the speculation deepens. Could this velocity, this relentless forward surge, carry more than the scars of gravitational scattering? Could it carry echoes of laws not quite like our own? If universes do recycle, collapsing, rebirthing, rewriting their physics each time, might an object like this preserve not just the chemistry of another age, but the momentum of another cosmos? Its speed is not just a number, it is an inheritance, a fossil not of matter but of motion. When we measure it, we reduce it to digits and decimals, but perhaps what we are really seeing is an echo of forgotten physics, a pace imprinted when the rules of the game were not yet the rules we know. Perhaps its flight is faster than it should be, not because of calculation errors or chance, but because it was born under different conditions, a universe with different balances of force, where speed itself carried other meanings. Even within the safety of science, the thought lingers. Speed is history. Every kilometer per second tells of forces encountered, distances crossed, the gravity wells escaped. And when we look at 3IATLAS, we are not just seeing an icy fragment moving through space. We are seeing the sum of its survival. Billions of years, billions of kilometers, written into the velocity that now carries it past our star. Imagine, for a moment, that you could ride alongside it. No ship, no engine, only yourself held in its gravitational shadow, moving with it through the void. Stars would not pass slowly. They would streak. The Milky Way itself would seem to drift differently beneath you. And yet, despite this breathtaking speed, time would feel endless, because there is no destination. Only motion, only continuity, only the story of speed preserved against eternity. And maybe that is its gift to us, to remind us that motion itself can be a memory. That speed is not just the distance between points, but the residue of all that has come before. In the glow of 3IATLAS, in its rush past the sun, we glimpse not only a comet but a chronicle one that tells us the universe is full of travelers who carry not just dust and ice, but the momentum of forgotten ages, and perhaps even of forgotten universes. For most comets, time is an enemy. They are fragile creatures, born from ice and dust, easily broken, easily erased. Within our solar system, the average comet lasts only a few million years before disintegration. Each close approach to the sun burns away layers of their frozen skin, fractures their cores, and leaves them fainter, weaker, until finally they vanish into silence. Even the giants of the Oort cloud, drifting for billions of years at the edge of interstellar space, are vulnerable to the smallest gravitational tugs. To survive is to endure against impossible odds. And yet, 3IATLAS has endured. Its journey, traced through its speed, its orbit, its chemistry, suggests an age not of millions, but of billions. Perhaps as much as 7 billion years older than Earth itself, older than the Sun, older even than the planets we call home. Imagine that. A fragment of ice and dust, fragile enough that a fingertip might crush it. Yet it has wandered intact across epochs that have swallowed entire stars. What trail has it followed through the dark? What paths has it carved across the galaxy while the Milky Way itself reshaped around it? In that span of time, galaxies have collided, stars have been born and died, civilizations have risen and fallen, if not here, then perhaps elsewhere, and through all of it, this comet survived. Its survival makes it an outlier among small bodies. To drift for so long without shattering, without losing itself to heat, without being pulled into the furnace of a star, is improbable in the extreme. It is as if the comet has been shielded, protected by circumstances we do not yet understand. Perhaps it lingered in the calm outskirts of a quiet star system, spared from close encounters. Perhaps it was ejected quickly, escaping while still young, never giving time a chance to erode its strength. Or perhaps, and here, speculation stirs like a faint wind in the void. Perhaps its endurance is not just a matter of chance, but of law. Imagine that our universe is not the first. Imagine cycles of cosmos after cosmos, each collapsing, each reborn, each rewriting its physics in ways both familiar and strange. Could 3IATLAS be a survivor of such a transition, preserved by rules that no longer apply to us, frozen in a state that should not have endured, and yet somehow did? Its persistence might not only be improbable, it might be impossible under the physics we know, and yet here it is, shining faintly in our telescopes. Think of it this way. Most comets are like voices on the wind. They whisper for a moment and then are gone, lost in the noise of time. But 3IATLAS is a voice that has carried for billions of years, a tone so steady it outlasted the silence of ages. Perhaps it was protected by sheer luck, or perhaps by deeper laws that existed before our universe found its present rhythm. A memory not just of stars and galaxies, but of the frameworks that once allowed them to exist. And when you look at it through that lens, its faint trail across the dark becomes something profound. It is not just dust drifting away. It is evidence of resilience written in light. Each particle it sheds carries within it the memory of survival, of billions of years endured without fracture. To see its coma glowing against the stars is to see the endurance of the cosmos itself, fragile, yes, but unbroken. Now pause and imagine this. You are standing beneath a dark sky far from cities where the Milky Way stretches above like spilled silver dust. You raise a telescope, and there it is, 3IATLAS, faint, almost ghostly. You know it has survived journeys older than the earth beneath your feet, older than the oceans, older than the mountains themselves. And you wonder, what secret allowed it to last so long? Was it born in a corner of the cosmos gentler than ours, or does it carry within it the fingerprints of laws that no longer exist, a relic preserved by a forgotten physics? Most comets do not last long enough to tell their stories. This one has. And in its trail through the darkness, in its improbable survival, lies the possibility that the universe is larger, stranger, and more layered than we have yet imagined. When astronomers calculated the likely age of 3IATLAS, the numbers stretched further than most of us can hold in our minds. Roughly 7 billion years. To say it simply is easy. To feel the weight of it is harder. This comet is older than the Earth, older than the Sun, older than the planets that circle it. When the solar system was nothing more than a swirling disk of dust and gas, lit faintly by a newborn star, 3IATLAS had already been wandering. Try to imagine that. When Earth was still only a possibility, this fragment of ice already carried within it the story of another time, another place. The continents had not yet formed. The oceans had not yet gathered. Life was not even a thought. And still, in some distant corner of the galaxy, this small traveler was already alive in its own quiet way, a frozen witness to an age before our age. 7 billion years ago, the galaxy itself was different. The sun had not been born. The Milky Way was younger, more chaotic, filled with collisions and mergers that stirred the stars into new patterns. Thick disk stars burned bright, remnants of earlier epochs of formation. Heavy elements were rarer, the chemistry of worlds less diverse than it is now. To be born in that age was to be shaped by conditions we can scarcely imagine: a galactic adolescence, full of violence and change. 3IATLAS may have been formed in the outer reaches of some ancient system, far from its parent star, where ices could freeze solid and endure. Perhaps it circled quietly for eons, unseen, until a gravitational nudge released it into the galactic sea. Or perhaps its home system did not survive at all, torn apart in the chaos of early galactic collisions, leaving this one fragment to drift free while everything else was lost. The thought alone is staggering, that we are looking not just at an interstellar traveler, but at a survivor from a time before our world began. A piece of matter that predates every mountain, every ocean, every breath of air we have ever known. And when you see it through that lens, its faint glow becomes something more than astronomical. It becomes ancestral. And here, speculation opens its doors a little wider. What if 7 billion years does not only mean before Earth, but something stranger? What if it was formed at a time when the universe itself was not yet stable, when the laws that now govern us were still settling into their present forms? Some cosmologists suggest that the constants of nature, the fine balances of force and energy, may not have always been exactly as they are. Could an object like this carry within it not only the chemistry of a forgotten star system, but the fingerprint of a cosmos still in flux? If so, then 3IATLAS is not just old. It is primordial, a fossil of physics itself, born when the universe still carried echoes of its own beginning. In its ice and dust might be patterns that no longer appear anywhere else, arrangements of matter that only existed in those first, turbulent billions of years. Imagine holding a piece of it in your hand, a fragment no larger than a pebble, and yet older than the world beneath your feet, older than the sun that warms you. It would be like touching time itself, a material older than memory, older than myth. You might look at its frozen structure and realize that it has witnessed events that no living thing ever saw, that it has endured not because it was meant to, but because endurance itself was possible in a way it no longer is, and perhaps that is the deeper mystery. What if the reason it has survived so long is because it carries with it the memory of a universe more resilient, more open to endurance than ours? What if its very survival is the evidence that our cosmos is not the first, but one in a series, and that 3IATLAS slipped through the boundary, carrying with it the rules of a world now erased? 7 billion years, a number that dwarfs us, that humbles us, that stretches imagination past breaking. And yet here it is, visible in our skies, allowing us to peer, however faintly, into a time before the Earth itself was even possible. To call 3IATLAS a fossil is to stretch the word beyond bone and stone into something much vaster. On Earth, fossils are fragile survivals, the preserved shells of trilobites pressed into Cambrian limestone, the delicate wings of insects captured in amber, the outlines of ferns etched in shale. Each one is a memory made solid, a life or a moment held against the relentless tide of decay. But even the oldest of these 300, 400, perhaps 500 million years old, are children beside the comet. 3IATLAS carries an age nearly 14 times greater. Its body is not a record of a single life or ecosystem, but of the galaxy itself, in an earlier state of being. What makes it different is the way it remembers. Earth is a forgetful planet. Its crust churns, subducts, melts, and reforms. Continents drift, mountains rise, oceans close. Fossils on our world are exceptions, fragile miracles rescued from oblivion by the rarest of circumstances. But the comet has not lived within such violence. It has drifted in silence, far from stars, far from heat and pressure. Its archive is unbroken. Every molecule of carbon dioxide locked in its ice, every fleck of dust embedded in its body, is a page in a book that has never been rewritten. Imagine, for a moment, being able to hold such a piece in your hand. A fragment no larger than a pebble, dark and brittle, but older than every mountain and every ocean. You turn it over in your palm, and you realize it has never felt the warmth of Earth, never been weathered by wind or rain. It has drifted for billions of years in temperatures close to absolute zero, preserving within it structures and signatures that on Earth would have been erased within weeks. It is not a fossil of bone or leaf, but a fossil of existence itself, unaltered, unbroken, enduring, where nothing else has. And this is where the imagination falters. For what exactly does it preserve? Is it simply the chemistry of a long-vanished star system, the ratios of isotopes, the arrangements of minerals? Or could it hold stranger records, ones that no human eye has yet conceived? Some cosmologists whisper that the laws of physics may not have been constant in the earliest epochs, that gravity, electromagnetism, even the balance of dark energy and matter might have shifted as the universe expanded and settled. If that is true, then 3IATLAS could be more than a fossil of time. It could be a fossil of physics, a body shaped by rules that no longer exist. Think about what that would mean. To find within it patterns of matter that cannot be explained by our universe as it is. To see ratios of elements that do not fit, structures of ice that should not endure. It would be like discovering a trilobite fossil that proves not only that trilobites lived, but that gravity once pulled in another direction. That time itself once flowed at a different rate. It would be evidence that our universe is not the first draft of reality, but only the latest in a series, and that this comet slipped through the seam between them, carrying the memory forward. Ancient cultures often imagined time as cyclical, not linear. The Maya spoke of suns that rose and fell, each world destroyed and remade. Hindu cosmology describes Kalpas, vast epochs where universes are born, dissolve, and are born again. Even Hesiod, in ancient Greece, wrote of golden ages replaced by silver, by bronze, by iron. Humanity has long suspected that the story of reality is one of repetition, of eras erased and renewed. What if 3IATLAS is the first physical proof, a fossil not only of a forgotten age, but of a forgotten cosmos? And so it drifts, silent, glowing faintly in our telescopes. It carries no words, no carvings, no glyphs. But fossils on Earth speak without language too. They speak through presence, through form, through the simple fact of survival. 3IATLAS may do the same. Its silence may itself be the message, that endurance is possible, that memory can stretch further than imagination, that even universes leave remnants behind. Now, imagine standing under the stars, telescope aimed at its faint glow. You know that you are looking at something that has carried memory longer than any mountain, longer than any sea, longer than the very planet on which you stand. And you wonder, what story does it tell? Is it the story of a star long gone, or the story of a universe erased before ours? Perhaps both. Perhaps the difference between the two is smaller than we think. In this way, the comet becomes not only an object of science, but of philosophy, a fossil of forgotten time, asking us whether time itself can truly forget. If age tells us how long the comet has endured, chemistry tells us where it might have come from. And here, 3IATLAS revealed another surprise. When astronomers captured its spectra, breaking its faint light into colors and lines, they found the fingerprints of gases streaming from its coma. There was carbon dioxide, abundant and insistent, far richer than what is typical for most comets of our solar system. But something was missing. Water, the usual lifeblood of a comet's glow, seemed strangely depleted. On Earth, we are used to thinking of water as the foundation. Our oceans cradle life, our rains feed the soil, our very breath carries traces of vapor. And when we think of comets, we imagine them as frozen reservoirs, icy relics of planetary birth. But here was an interstellar wanderer that defied that expectation. A body whose chemistry leaned away from water and toward carbon. Its ices were not dominated by the familiar, but by something more alien. This puzzled astronomers. Was it a simple matter of distance? Perhaps it formed farther from its star, in regions so cold that carbon dioxide froze in abundance, while water was left scarce. Or perhaps it was born in a system where water itself was rare, where hydrogen and oxygen never mingled in sufficient numbers, leaving carbon to shape the solid bodies instead. If so, then 3IATLAS is not merely unusual, it is a message about diversity, a reminder that our solar system's recipe is not universal, that other kitchens of creation stir with different ingredients, different balances, different outcomes. Now pause and imagine what such a world might have been like. Picture a star with planets circling in silence, but without oceans. No seas glittering in sunlight, no rivers carving valleys. Instead, imagine landscapes where carbon dioxide snow falls in faint, dry flakes, where the air is sharp and thin, where life, if it arose at all, followed paths we could scarcely imagine. A world where the chemistry of survival was written not in water, but in carbon. And here the speculation deepens. What if such a world did exist? And what if it was lost? Perhaps its star burned out long ago, or was torn from its system by a galactic collision. Perhaps its planets crumbled, its oceans, if it ever had them, boiled away. But one fragment, small and quiet, endured. It carried with it the memory of that alien chemistry, and after billions of years, it found its way to us. Not as a planet, not as a living world, but as a single shard, a comet with a carbon-rich heart. We often say that comets are time capsules, but this one feels more like a language, a dialect of chemistry from a place we will never visit. To study it is to read a sentence written by another star, a line of poetry composed not in words but in atoms. And the meaning of that sentence may be this: not all worlds are like ours. Not all beginnings follow the same script. Consider what this means for our search for life beyond Earth. If 3IATLAS is typical of some class of interstellar wanderers, then perhaps there are countless systems where water is not the foundation. Systems where chemistry took other paths, where life, if it found a foothold, grew upon elements we do not think of as nurturing. Could there be beings who breathe carbon dioxide as easily as we breathe oxygen? Could there be ecosystems sculpted from ice and carbon, strange forests where water is not the river of life, but the absence? The comet does not answer these questions. It only offers us the puzzle, the trace, the faint glow of gases escaping into the dark. But even in that silence, it speaks of possibility. It tells us that the cosmos is broader than our narrow assumptions, that if we listen only for water, we may miss the voices of worlds shaped differently, and perhaps that is its greatest gift, to remind us that life, memory, and meaning may take forms far beyond what Earth has taught us. That carbon itself may write the stories of worlds, not as a partner to water, but as the central element, the script, the ink. 3IATLAS, in its alien chemistry, whispers that creation is not singular. It is plural, infinite, diverse. Now close your eyes and imagine again that faint, glowing halo. Imagine its gases streaming away, each molecule a word from a forgotten language, each line of its spectrum a sentence. You may not yet know how to translate it, but you know it is a message that says, there are other ways to be a world, other ways to endure, other ways to remember. If the gases of 3IATLAS tell us about its chemistry, its dust tells us about its ancestry. For every comet, dust is more than debris. It is stardust, born in the fires of suns, preserved through unimaginable spans of time. And in this comet, drifting across our skies for a brief season, the dust carries the fingerprints of stars that no longer exist. Astronomers believe much of its material was forged in the atmospheres of ancient, metal-poor stars, suns that lived fast and died long before our own was born. In the early galaxy, heavy elements were scarce. Worlds formed from simpler recipes, made not from the rich palette of metals we know today, but from the basic building blocks of carbon, oxygen, nitrogen. To touch this comet would be to touch matter older than our sun, older than our solar system, shaped in stellar furnaces that flared and vanished before Earth was even a dream. Each grain of dust is like a fossil in its own right, carrying isotopic ratios that are unlike those found here. Oxygen isotopes, carbon isotopes, traces of silicon and magnesium, arranged in ways that tell a story of stars we will never see. Some of these grains are pre-solar, meaning they formed not around our sun, but around other stars entirely, and survived the collapse of gas and dust that built our system. To find them in 3IATLAS is to find an archive of stellar history, a message written not in words, but in isotopes and atoms. Pause for a moment and imagine that dust. It is finer than sand, finer than ash, drifting in the coma like a veil. To the eye, it is nothing, a shimmer too faint to see. But under a microscope, each particle is a cathedral of memory. Within it lies the rhythm of nuclear fusion, the scars of explosions, the whispers of stars that lived and died billions of years ago. And here speculation rises. Because if this dust preserves the story of ancient stars, could it preserve something stranger still? What if some of these grains are not just relics of stellar death, but relics of a universe erased? If reality itself has cycled, collapsing and rebirthing across infinities, might some matter endure between them, slipping through like seeds carried across fire into new soil? Could 3IATLAS carry not only the memory of forgotten suns, but the memory of forgotten universes? Imagine, for a moment, that you hold one of those grains. It is invisible on your fingertip, lighter than a whisper, and yet, within it, may be encoded the physics of another cosmos, the chemistry of laws no longer present. Its isotopic fingerprints may not just tell us about where it was formed, but when, and under what conditions of being. It might be matter that remembers a cosmos older than time as we measure it. In ancient traditions, dust was never just dust. In Mesopotamian myth, humanity was said to be formed from clay, mixed with divine breath. In the Bible, the refrain is simple: "For dust thou art, and unto dust shalt thou return." In Hindu cosmology, the gods themselves churned the cosmic ocean to bring forth the elements, dust and fire together. And always, dust was memory. Dust was origin. Dust was destiny. Now here, drifting past us, is dust not from Earth, not from the sun, not even from our era of the galaxy, but from a time so remote it predates our sky. To breathe it in, if that were possible, would be to breathe the exhalation of forgotten stars. To hold it would be to cradle a fragment of the cosmos in its earlier tongue. And to study it may one day tell us if there were not only forgotten stars, but forgotten worlds, and perhaps even forgotten universes. Perhaps that is the true meaning of its dust. That memory is not always held in stone or in books, but in atoms themselves. That the universe remembers even when we forget. And 3IATLAS, in its passing, offers us a handful of dust as proof. When 3IATLAS appeared in our skies, it did not come as the first of its kind. 2 other wanderers had preceded it, like distant siblings arriving at different times, each carrying a different message. To place Atlas in context, we must look back at those earlier encounters. Together, the 3 tell a story not of similarity, but of contrast, a tale of variety so broad it unsettles our sense of what interstellar visitors should be. The first was one, Oumuamua, discovered in October of 2017. Its name, chosen from Hawaiian, means a messenger from afar arriving first. And it truly was. Oumuamua tumbled into our solar system silently, a small, elongated fragment no more than a few hundred meters long. Unlike Atlas, it carried no coma, no halo of gas and dust to reveal its chemistry. It was dry, inert, silent. What made it strange was its shape, a long, slender body, some argued like a cigar, others like a pancake, spinning in a way that suggested something never before seen. Its brightness changed so rapidly that astronomers struggled to understand its rotation. And strangest of all, it seemed to accelerate ever so slightly as it left us, as though something more than gravity were at work. Some suggested outgassing too faint to see. Others whispered darker speculations. An alien probe, a shard of technology. But whatever it was, it came and went without leaving a clear answer. 2 years later, in 2019, came the second 2I, Borisov, discovered by amateur astronomer Gennady Borisov in Ukraine. This one was different. Where Oumuamua had been silent, Borisov was loud. It carried a coma, it carried a tail. It looked like a classic comet, except it was not from here. Its chemistry was unusual but not alien, with signs of carbon monoxide in abundance. It was larger, brighter, easier to study, and it reassured us in a strange way. If Oumuamua had been the unsettling messenger, Borisov was the familiar one, the comet that said, yes, interstellar space contains bodies much like those in our own system. And then came 3IATLAS, in July 2025. Where Oumuamua had been silent and Borisov had been familiar, Atlas was fast. It was old. It was chemically strange, rich in carbon dioxide, poor in water. It moved against the flow, retrograde, with an eccentricity so great it made the other 2 look almost tame. In its brief passage, it became the fastest interstellar visitor yet known, carrying with it the weight of billions of years. To compare them is to see a puzzle with pieces that do not fit. Oumuamua, dry, elongated, mysterious. Borisov, icy, familiar, comet-like. Atlas, ancient, fast, carbon-rich, older than our world. No 2 share the same profile. No 2 tell the same story. And that, perhaps, is the point. Because if the galaxy is filled with trillions of such wanderers, fragments of systems lost, ejected, scattered, then why should we expect them to be alike? Each is the survivor of a different story, a different star, a different collapse or collision. Each carries not only matter, but history. And when we place them side by side, the diversity itself becomes the message, that the galaxy is a patchwork of forgotten worlds, and each shard that reaches us is a page torn from a different book. Now, pause and imagine these 3 visitors as travelers meeting by chance at a crossroads. Oumuamua, thin and silent, a mysterious stranger who speaks in riddles. Borisov, loud and bright, a familiar wanderer with an open story to tell. And Atlas, old and fast, a sage carrying memories older than Earth itself. They do not resemble one another, and yet together they suggest that the road is full of countless others we will never see. This raises a speculative question. What if they are not merely fragments of random systems, but shards of deeper cycles? What if each one carries not only the memory of a lost star system, but of a forgotten universe? If universes collapse and are reborn, each with its own physics, its own chemistry, its own patterns of creation, then perhaps these visitors are not only interstellar but intercosmic. Messengers not just from distant stars, but from realities erased before ours began. It is a thought both exhilarating and unsettling, because it means that when we look at 3IATLAS through our telescopes, we are not just seeing a comet. We are seeing a page from a story older than Earth, older than the Sun, older perhaps than the laws that govern us. And when we set it beside Oumuamua and Borisov, we see not one story, but three fragments that hint at a library of forgotten universes drifting invisibly through the dark. Take a deep breath and imagine them together. 3 lights crossing the solar system, each on its own unrepeatable path, each never to return. 3 messengers, each carrying secrets from beyond, none of which we may ever fully decode. And yet, in their diversity, in their strangeness, they remind us that the cosmos is not uniform, not simple, not easily contained. It is vast, layered, and filled with messages we may never finish reading. It is tempting, when faced with the unknown, to search for categories. We like to place things in neat boxes, comets here, asteroids there, planets in their orbits, stars in their constellations. Our minds find comfort in order, in the belief that everything has a type, a pattern, a definition. But with the arrival of these 3 visitors, Oumuamua, Borisov, and Atlas, that comfort begins to dissolve. Taken together, they do not fit. They defy the lines we try to draw. Oumuamua lacked the bright coma of a comet, yet its trajectory said it was no asteroid of our own. Borisov glowed like a classic comet, but carried chemical surprises, as though its icy recipe had been written in another kitchen. Atlas, ancient and restless, sped through with its strange carbon-rich signature, older than the Earth itself. No 2 resemble one another, and no single category holds them. Instead, they are 3 worlds, 3 stories, each one a fragment of something larger, each one carrying a tale from a place we will never see. And when you place them side by side, you begin to feel that they are not just exceptions to the rule, they are the rule. That the galaxy is not filled with uniformity, but with difference, with fragments that each tell their own unrepeatable story. Imagine them as 3 voices in a choir, each singing in a different key. One high and sharp, one low and steady, one older, deeper, carrying a resonance we do not recognize. To listen to them together is not to hear harmony, but to hear the vastness of possibility. To hear that the universe does not repeat itself, but invents endlessly, scattering unique creations across space like seeds on the wind. And here, speculation stirs. What if these 3 are not only the first we have seen, but the first hints of a much larger truth? What if each one is not only a fragment of a lost system, but a shard of a forgotten cosmos? Imagine that universes rise and fall, not once, but many times. Each collapse scattering remnants, each rebirth shaping them anew. Could these interstellar visitors be the fossils of such cycles, carrying the memory of realities that no longer exist? Oumuamua then becomes more than a mystery. It becomes a shard of silence, a fragment that remembers a universe where outgassing and shape followed rules we do not share. Borisov becomes more than a comet. It becomes a witness to a chemistry that grew in a cosmos slightly different from our own. And Atlas becomes more than a traveler. It becomes an elder, a messenger from before Earth, carrying not just dust and ice, but the memory of another order entirely. Pause and let that thought settle. You are not just looking at 3 space rocks. You are looking at 3 possible echoes of forgotten worlds, 3 messages that slipped through the cracks of time and found their way to us. Their diversity is not an accident. It is a hint that the cosmos does not forget entirely, that it leaves behind fragments, clues, fossils scattered through the stars. Ancient traditions often spoke of 3 messengers, 3 guardians, 3 figures who came together to signal change. In Norse myth, the 3 Norns wove the threads of fate. In Greek tradition, the Moirai, the Fates, spun, measured, and cut the lives of mortals. In Hindu stories, the Trimurti Brahma, Vishnu, Shiva embody creation, preservation, and destruction. Always 3, always different, always a cycle. Perhaps our 3 cosmic visitors echo this pattern. The silent one, the familiar one, the ancient one. Creation, continuity, and memory. And maybe that is why they unsettle us so deeply. Because we sense, even without proof, that they are not random. That together they form a story larger than any one of them could carry. A story that says, you are not alone in the universe. Not because others are watching you, but because others have been here before. Universes have risen and fallen, stars have burned and died, and yet their fragments cross your sky. Close your eyes and imagine them once more. Oumuamua, a silent shard of mystery. Borisov, a bright echo of familiarity. Atlas, an elder fossil of forgotten time. 3 messengers, 3 worlds, 3 stories. And perhaps, if we listen closely enough, we will hear in their passing the reminder that the cosmos is not only vast, but layered with memory. That every fragment carries not just its own tale, but the echo of something larger, something we are only beginning to glimpse. When astronomers traced the trajectory of 3IATLAS backward, they found something unusual. Its path did not seem to link it with the thin, orderly plane of the Milky Way, where most stars, including our Sun, reside. Instead, its velocity and inclination suggested an origin in the galaxy's thick disk, a structure older, rougher, and stranger than the thin spiral arms we usually picture. The thick disk is a fossil of the galaxy's own turbulent youth. Its stars are ancient, dating back more than 10 billion years, born during an era when the Milky Way was colliding with other protogalaxies. Its structure chaotic, its chemistry sparse. These stars are metal poor, formed before supernovae had enriched the galaxy with heavier elements. They shine with a colder light, carrying within them the memory of an age when the Milky Way itself was still assembling. To say that 3IATLAS may come from this thick disk is to say that it is not just older than Earth. It may belong to a different order of the galaxy entirely. An age before the spiral settled into its familiar form, before the thin disk with its well-behaved stars like our Sun even came into being. It may be a refugee from chaos, a fragment ejected during the Milky Way's violent adolescence, when collisions with dwarf galaxies stirred the stars like a storm stirring a sea. Pause and imagine this history. The Milky Way not as a graceful spiral, but as a young, unruly structure, colliding, devouring, reshaping itself. Star clusters tearing apart, planets flung into the dark, comets scattered like sparks from a fire. In such an age, countless small bodies would have been cast adrift, freed from their home systems, sent wandering into interstellar night. 3IATLAS may be one of them, still carrying the chemistry and memory of that lost epoch. And here, speculation deepens. If the thick disk represents an older order of the galaxy, a phase when stars formed under different conditions, with fewer metals, with more primitive chemistry, then perhaps 3I-ATLAS carries within it the imprint of that order. Its carbon-rich, water-poor composition may be a direct reflection of a galactic environment less generous with oxygen, less able to form water-rich worlds like ours. It may be a relic of a time when the building blocks of life, as we know them, were scarcer. But what if we look further still? What if the thick disk does not only represent a different epoch of the Milky Way, but a different cosmic cycle? Some cosmologies suggest that galaxies themselves may carry scars of earlier universes, that structures formed in one cycle can survive, collapse, and be reborn in another. If so, then 3I-ATLAS may not only be a refugee of galactic collisions, it may be a refugee of universes, a fragment that slipped through, carrying with it the imprint of laws and conditions that are no longer present in our own. Imagine standing at the edge of a vast ocean, watching waves crash in from different storms. Each wave carries its own foam, its own driftwood, its own fragments of places far away. The thick disk of the galaxy is like that, a sea of stars and debris carried forward from ancient collisions. And 3I-ATLAS may be a single piece of driftwood, cast ashore not from one storm, but from storms beyond counting. For astronomers, linking an interstellar comet to the thick disk is like finding a fossil not only older than your continent, but older than the world as you know it. It ties the small and fragile to the immense and ancient. It tells us that even a body only a few kilometers wide can carry the story of structures larger than imagination, structures that shaped the galaxy long before our sun was born. Now, close your eyes and imagine that comet once more, not just as a fragment drifting past Earth, but as a survivor from a galactic age when the Milky Way itself was raw and untamed. A shard of a different order, a reminder that our galaxy is layered with history upon history, and that even the smallest messengers may carry the memory of those forgotten layers. There are ideas in cosmology that feel more like whispers than theories, spoken softly at the edge of physics. One of them is this, that our universe may not be the only one. That time itself may be cyclical, stretching through endless epochs of collapse and rebirth. A cosmos that expands, cools, and eventually falls back in upon itself, only to ignite again, reshaping matter and laws anew. Some call it the bouncing universe, others a cosmic cycle, but the heart of the thought is simple. Perhaps what we know is only one chapter in an infinite book. If that is true, then we can ask a haunting question. What survives the turning of the page? When a universe collapses, when galaxies fold inward and stars are devoured, when time itself approaches silence, could anything remain? Could matter slip through the seam, emerging in the newborn cosmos on the other side? Most scientists would say no. The laws as we understand them suggest that all structure is erased, reset, rewritten in the fire of rebirth. But some allow themselves to wonder, what if not everything is lost? What if there are fragments that endure, like fossils embedded in the fabric of space, passed from one universe to the next? And if such fossils exist, what would they look like? Not galaxies, too large to survive, not stars, too fragile to persist. Perhaps they would be small things, compact, hardened, wanderers like comets, capable of slipping between cycles, carrying within them the memory of the cosmos that came before. It is here that 3I-ATLAS becomes something more than just an interstellar visitor. Its age already predates Earth. Its chemistry is strange, its orbit unbound, its endurance improbable. But what if these traits are not only the marks of interstellar wandering, but of intercosmic survival? What if it is not only a fragment of another star system, but of another universe entirely? Pause with me and imagine this. A universe comes to its end. Stars collapse. Galaxies fall inward. The very fabric of space folds upon itself. Amid that cataclysm, countless fragments are consumed, erased without trace. but a few, perhaps only a handful, find pathways through. They slip into the newborn cosmos, not as deliberate messengers, but as survivors of physics itself. They enter carrying the chemistry, the laws, the memory of what once was, and then they drift, unnoticed, for billions of years. Until at last, one crosses our path, glowing faintly in our skies. If that is the case, then 3IATLAS is not simply old, it is eternal, a fossil not only of time, but of existence itself, a body that remembers a universe no longer here. This speculation is not so different from the myths that humanity has carried for millennia. In Hindu cosmology, universes are born and destroyed in cycles, each lasting for billions of years, each followed by another. In Norse myth, Ragnarok ends the world, but a new one rises from its ashes. The Maya spoke of successive suns, worlds born and broken, each leaving traces in the one that followed. Always the cycle, always the rebirth, always the memory carried forward. Now, science gives us its own version of the same story. The idea that universes may recycle, that the Big Bang may not have been the first, nor will it be the last. And if this is true, then 3IATLAS becomes something uncanny. It is no longer just a comet, no longer just a messenger from another star. It is a messenger from another reality, a shard of a forgotten cosmos delivered into ours by the turning of the cosmic wheel. And perhaps this is why its passage feels so significant, because we sense, in its brief glow, that it carries something beyond us, something not entirely of this universe, a fossil not just of forgotten time, but of forgotten existence, a memory that has crossed boundaries we cannot yet imagine. Now, close your eyes. Picture the night sky above you, vast and endless. Somewhere within it, a small point of light drifts, ancient and silent. You know it is not from here. You know it may not even be from now. And in its glow, faint but insistent, you hear a question. What if every comet, every shard, every grain of dust that drifts between the stars is a memory not just of this cosmos, but of many? And 3IATLAS, in its passing, may be our first glimpse of that truth. When word of 3IATLAS reached the scientific community, it did not slip quietly into obscurity. Instead, like a bell struck in a darkened hall, it set the world's telescopes ringing with attention. From Chile's Atacama Desert to the islands of Hawaii, from European observatories perched in alpine stillness to radio arrays stretching across the plains of Australia, instruments turned their eyes to the faint glow of this visitor. It was not simply curiosity that pulled them, but urgency. Interstellar objects do not linger. They are here, and then they are gone. Every night mattered. Every photon captured was a memory saved. Imagine that sense of urgency. Teams coordinating across time zones, scheduling precious telescope hours, racing the inevitable dimming of the comet as it slipped further from the sun. Researchers who had never before spoken now shared data in late-night calls, united by the fragile opportunity to glimpse something older than Earth itself. Astronomers accustomed to slow patience found themselves caught in something rare, the thrill of immediacy, a countdown, a reminder that discovery is often less about finding than about not missing. The data that emerged confirmed what had been suspected. This was perhaps the oldest comet humanity had ever witnessed. Its estimated age, 7 billion years, placed it not only before the Earth but before the Sun, before the familiar planets, before the solar system itself had condensed from gas and dust. Its orbit hyperbolic, eccentric, retrograde left no doubt. It was a traveler, not a native. Its chemistry, strange and carbon-rich, whispered of origins far outside our local norms, and its survival, intact after billions of years adrift, challenged the quiet assumptions about how fragile small bodies must be. Yet amid the data, amid the careful analysis and peer-reviewed precision, something else stirred. a quiet unease. Scientists are trained to resist dramatics, to hold speculation at arm's length. And yet, even within professional circles, words like eerie, uncanny, unsettling crept into the margins. For all its measurable qualities, 3IATLAS felt different. Perhaps it was its age, perhaps its speed, perhaps simply the recognition that something so old, so alien, had chosen this moment to pass within our reach. Close your eyes and picture those scientists. Tired eyes red from staring at monitors, coffee cooling on desks, the hum of equipment filling otherwise silent rooms. Imagine them stepping outside after a long night, looking up at the same faint point of light they had been passing in graphs and charts. Imagine the shiver that comes, not from data, but from recognition that the thing above is older than the continents beneath their feet, that it carries in its dust the memory of stars that burned out before Earth's oceans were born. Some spoke of it in hushed tones. Some joked nervously, as people often do when faced with something too large to process. But beneath it all was the same feeling, that this was no ordinary comet. It was, in a way, a mirror showing humanity its place in the timeline, showing how brief our civilizations are compared to one grain of interstellar ice. And perhaps, just perhaps, hinting that the universe does not only expand outward, but backward, into memories and remnants we can barely comprehend. And so the telescopes kept turning, night after night, following 3IATLAS as it slipped away, its coma thinning, its trail dispersing. Every photon recorded was a rescue of sorts, saving from silence the story of an object that might never be seen again. Science responded with all its rigor, all its coordination, all its hunger for knowledge. But even in that rigor, there was wonder. Even in the careful phrasing of journal articles, there was an undertone, an admission without words that sometimes, even in science, discovery feels less like measurement and more like revelation. Long before telescopes and spectrographs, long before orbits could be plotted on chalkboards or coded into simulations, humanity looked up and saw comets as omens. A streak of light across the night was never neutral. It was a sign of upheaval, of death, of change. Kings trembled. Empires prepared for downfall. Priests stepped forward to interpret the sudden fire in the sky. To the ancient eye, comets did not belong to the ordered motions of the heavens. They came unbidden, unpredicted, from the edge of the known world, and so they carried with them the weight of the unknown. The Chinese court astronomers catalogued them for centuries, drawing careful diagrams of their tails, noting whether they were curved or straight, pale or crimson. Each variation meant something: the rise of a dynasty, the fall of a general, the approach of famine or war. In medieval Europe, the sight of a comet could silence entire towns. Its glow understood as divine commentary written across the heavens. The Bayeux tapestry shows Halley's comet blazing over the year 1066, embroidered above soldiers and ships, a heavenly sign woven directly into the fabric of conquest. In Mesoamerican traditions, fiery visitors across the sky were tied to the rhythms of gods and worlds, signals of cycles larger than human life. These were not foolish fears. They were expressions of a deep truth that comets arrive from outside the ordinary order, bearing no allegiance to the familiar. And when something breaks into the known world from outside, humans instinctively grant it meaning. Now, in an age of science, we might imagine ourselves immune to such impulses. We can calculate orbits, measure spectra, estimate compositions. We can describe sublimation in the language of chemistry, mass loss in the language of physics. We can say, without hesitation, that 3IATLAS is a body of ice and dust, rich in carbon dioxide, poor in water, older than Earth, moving along a hyperbolic path it will never retrace. And yet, when it appeared, the old reflex stirred again. Astronomers, careful and cautious, whispered of its uniqueness. Writers invoked words like messenger and memory. Even the public, reading headlines, sensed that this comet was not just an object, but a story. 3IATLAS revived something ancient, the recognition that visitors from beyond always come carrying more than themselves. In earlier centuries, we called that gift prophecy. Now, perhaps, we might call it memory. Instead of warning us of a king's downfall, it reminds us of time itself, vast, unbroken, humbling. Instead of forecasting famine, it shows us endurance, how a fragile body can survive for billions of years, where planets and civilizations crumble. Imagine standing beneath the night sky with both perspectives layered over one another. On the one hand, the scientist's view, a rare interstellar comet, classified, catalogued, observed. On the other, the ancient seer's view, a messenger carrying news from beyond, a light that signals change. The two are not as far apart as they seem. Both recognize that such an arrival is not trivial. Both know that it matters when something old, alien, and transient passes through our world. And so, 3IATLAS becomes a kind of bridge. It shows us that myth and science are not opposites, but two ways of listening to the same silence. One listens with symbols, the other with numbers. One whispers of omens, the other of isotopes. Both agree on the essential point. This comet is not just debris. It is meaning, written against the darkness. Speculation follows naturally. If earlier civilizations saw comets as messengers of change, then perhaps 3IATLAS is a messenger too, not of future events, but of forgotten realities, not prophecy, but memory. Its carbon-rich chemistry speaks of alien worlds. Its dust carries the fingerprints of stars that no longer burn. Its survival tells us that the universe remembers more than we imagine. Close your eyes and hold that thought. A comet as memory. Not a warning of what is to come, but a reminder of what has already passed. A fossil of time, a messenger of endurance. A sign, not of doom, but of continuity. And in that sense, the myth returns not as fear, but as reverence. The sky still speaks. The difference is only in how we choose to listen. Imagine, for a moment, a world where no messengers ever come. A planet sealed within its own system, gazing at stars but never touched by them. In such a world, Earth's story would be written only in local chapters. The birth of the sun, the cooling of molten crust, the slow rise of oceans, the emergence of life. The geology would still shift. The mountains would still rise and fall. The forests would still spread and wither. But all of it would be insular, inward-looking, a narrative contained within its own boundaries. Without interstellar visitors, we would never know what lies beyond our neighborhood in any tangible way. We could look with telescopes, yes, study spectra of distant stars, count exoplanets crossing in front of their suns, but we would never hold in our hands matter that came from another system. Our science would be like a listener standing outside a house, pressing an ear to the wall. You can hear muffled voices, you can guess at conversations, but you will never know the taste of the food on the table or the smell of the fire in the hearth. Oumuamua, Borisov, and Atlas opened the door, however briefly. They carried more than dust and gas. They carried physical proof that other kitchens of creation cook with different recipes. Oumuamua's silence, Borisov's bright tale, Atlas's ancient carbon signature, each one a fragment that tells us our way is not the only way. Without them, our science would be blinder, narrower, convinced perhaps that what we see here is all that can be. Think about what would be lost. No evidence of interstellar chemistry. No direct samples of dust forged in the atmospheres of stars older than our own. No proof that planetary systems everywhere eject fragments, scattering them across the galaxy like seeds on a wind. We might still imagine such things, but imagination is not the same as touch. To study an interstellar object is to close the distance between dream and evidence. Without them, that distance remains untraveled. And perhaps more importantly, we would lose the chance to glimpse what might have been. For each of these visitors is not only a piece of rock or ice. It is a possible history, a record of a world we will never see, a star that may no longer exist, a system whose planets might have thrived or died billions of years before Earth began. Without them, we would live on a planet without mirrors, unable to see how other stories might have been written. Now, pause and imagine this silence, a sky full of stars, but no travelers crossing it. No comet tails from beyond, no sudden visitors on unrepeatable paths. Earth would know only itself. Humanity would build its sciences from local stone and sky, never realizing that we were missing entire libraries of memory, drifting just beyond reach. Our myths might have been poorer too. Comets have always stirred imagination, omens, signs, messages. Without them, perhaps the night sky would feel emptier, less alive, less like a place of dialogue, and more like a stage set fixed in place. Speculation rises here. What if that silence had continued? What if 3IATLAS had passed unseen, or had never come at all? Humanity would remain blind to hints of forgotten worlds. We would not know that matter can survive billions of years adrift. We would not be able to imagine, with evidence in hand, that perhaps some fragments come not only from other stars, but from other universes. We would live with a smaller cosmos, one defined by what is near, not what is possible. And perhaps that is the greatest gift of these visitors. They break the illusion of isolation. They remind us that our world is not an island but part of a sea, and that across that sea, currents carry messages. To be a planet without visitors is to be a planet without conversation. To be a planet with them is to be part of a dialogue older than language, older than Earth, older than the stars themselves. Astronomers now suspect that interstellar comets are not rare exceptions, but the rule. Our telescopes catch only a handful, those that happen to pass close enough and bright enough for us to notice. But in truth, the galaxy may be filled with them, trillions upon trillions of wanderers drifting between the stars, each one a shard broken from its birthplace, each one a survivor of forces larger than itself. Imagine it, a galactic ocean not empty, but full of debris. Every star system, in its birth, in its collisions, in its deaths, casts fragments outward. Some are planets ejected by gravitational tides, sent spiraling into eternal exile. Others are icy bodies flung beyond the reach of their suns. Over billions of years, the galaxy becomes seeded with them, until interstellar space is less a void and more a slow migration of orphans. 3IATLAS is only one such orphan, briefly illuminated by its encounter with our sun. Most will never glow, never reveal themselves. They drift dark, invisible, indistinguishable from the emptiness around them. Whole rivers of them may pass unnoticed through our neighborhood, shadows among shadows. The fact that we have seen only 3 so far is not proof of rarity, but of our blindness. Our instruments are young, our awareness narrow. The universe has been carrying this traffic for eons. Pause and let that scale settle in your mind. Trillions, each one carrying within it a story of loss and endurance. Each one a fragment of a star system shattered, a planet destroyed, a disk disrupted. 1 trillion fossils moving silently across the galaxy, unseen but not absent. If Earth's museums are filled with trilobite shells and petrified wood, then the galaxy's museum is filled with these wanderers, each one a specimen, each one a record. And here speculation stirs again. If the universe recycles, if realities collapse and are reborn, then perhaps some of these wanderers are not just fragments of lost systems, but fragments of lost universes, fossils not of planets, but of cosmoses themselves. A trillion reminders that nothing is erased entirely, that memory always finds a way to persist. It is a haunting thought that between the stars, drifting unseen, are relics of universes older than our own. Perhaps their chemistry bears fingerprints of laws that no longer hold. Perhaps their isotopes are records of processes that no longer occur. Perhaps, if one were ever captured and studied, it would reveal not only where it came from, but when and from which chapter of existence. In ancient times, wanderers were always symbols: the exiled hero, the lost tribe, the pilgrim crossing deserts in search of a home. To be a wanderer was to carry memory forward, and in that sense, the galaxy itself is full of pilgrims. Each interstellar comet is a traveler with no destination, carrying in silence the history of a place that no longer exists. Close your eyes and picture them, not one or two, but countless, drifting through the dark like embers carried on a cosmic wind. Some passing close to stars, waking briefly into comae before falling back asleep. Others lost in the deep, never warmed, never seen. Together they form a hidden population, a diaspora of matter spread across the galaxy. And in their sheer number, they tell us something profound: that the universe is not empty, it is filled with memory. When we study one like 3IATLAS, we are not studying an anomaly. We are studying one voice in a vast choir, a single page from a library that spans the galaxy. And if we listen carefully, if we continue to sharpen our instruments and extend our patience, perhaps we will begin to hear that choir in full. A chorus of wanderers, each carrying not prophecy, but remembrance. Speculative thought pushes further still. What if these trillions of wanderers are not only passive fossils, but active carriers of continuity? Seeds of chemistry, scattered across time and space. Perhaps life itself rides on their surfaces, frozen but not extinguished, waiting for a hospitable shore. Perhaps memory itself is not an accident, but a strategy of the cosmos, to ensure that nothing is ever fully lost, that each universe leaves remnants in the next. In this way, the wanderers are not just debris, they are legacy, they are continuity. They are the threads that stitch together epochs and eras, stars and galaxies, universes and rebirths. 3IATLAS, then, is not alone. It is one among countless messengers, each drifting silently, each offering us the chance to remember more than our own small story. And if we miss them, if they pass unnoticed, the loss is ours. For the universe is always speaking. It speaks in starlight, it speaks in gravity. And sometimes it speaks in comets, briefly visible, briefly luminous, before vanishing again into the dark sea from which they came. Suppose we strip away the speculation. No whispers of universes erased, no suggestion of forgotten laws stitched into its dust. Suppose we look at 3IATLAS with the narrowest, most cautious eye possible. Then what is it? A comet, debris from the outskirts of some ancient planetary system, a fragment flung outward by gravity, wandering for billions of years in the deep, before chance carried it into our neighborhood. That is all. And yet, that is enough. Because comets, even the ordinary ones from our own solar system, are already emissaries of deep history. They are the leftovers of planetary birth, the fragments that never became planets, moons, or asteroids. When a star forms, it gathers dust and gas into a disk, a whirling sea of particles colliding, clumping, merging. Most of that matter is swallowed by the star or assembled into planets. But not all. The outer regions of such disks are littered with icy remnants, small bodies too scattered and too cold to ever grow larger. They are flung outward by the gravitational tug-of-war of young giants, cast into reservoirs on the edges of systems. That is what comets are, the fragments that remain, the fossils of beginnings. Now imagine this process not in our own solar system, but in another, billions of years ago, around a star that may no longer exist. a star forms. A disk gathers. Planets grow. Fragments scatter. One shard, no larger than a mountain, is cast outward, not to rest in some stable cloud, but into the endless dark of interstellar space. It drifts there for eons, silent, untouched, until by chance it falls into the path of our sun and blooms into visibility for the briefest of seasons. That shard is 3IATLAS. Even in this restrained interpretation, there is wonder. Its age alone is enough to stagger imagination. Estimated at 7 billion years, it predates Earth. It predates the Sun. When this comet condensed out of dust and gas, our galaxy was younger, its stars fewer, its metals scarcer. Dinosaurs, continents, oceans, even the blue sky above us, all of these are younger. To look at 3IATLAS is to look at a survivor older than Earth itself. Its speed is equally humbling, 58 kilometers every second. That is more than 200,000 kilometers every hour. In the time it takes you to take a breath, it has traveled dozens of miles. No spacecraft we have ever built, not even the Voyagers with their decades of acceleration, can match that pace. 3IATLAS moves with a velocity shaped not by human engineering, but by galactic time, by billions of years of gravitational slingshots across starfields we will never see. And then there is its orbit, hyperbolic, eccentric, retrograde. It will pass once and never return. Our solar system's comets come and go in long cycles, some taking hundreds or thousands of years to complete their loops. But they are bound. They belong here, 3IATLAS does not. It is not a citizen of our system. It is a visitor, a traveler, who will not stop long enough to rest. To study it is to study a fleeting moment, a stranger passing through, one glance exchanged before they disappear into the crowd forever. If it is only a comet, then its chemistry is still extraordinary. Unlike most local comets, it is rich in carbon dioxide but strangely depleted in water. That simple fact tells us something profound, that not all systems are alike. Some worlds are born in water-rich environments, others in carbon-rich deserts. The galaxy is diverse, and comets are its proof. They are nature's postcards, carrying the signatures of their home systems. To analyze one is to glimpse the recipe of another kitchen, the ingredients of another creation. Even its survival is a marvel. Interstellar space is not gentle. Cosmic rays bombard, collisions fragment, stars flare and tug. Most comets disintegrate within millions of years. Yet 3IATLAS endured for billions, long enough to wander across galactic epochs and arrive here intact. How? Was it shielded by layers of carbon ice, preserving its fragile heart? Was it simply lucky, missing collisions by margins so slim they could never be measured? Whatever the reason, its endurance alone is miraculous. And perhaps that is enough. We need not call it anything more. To honor it as a comet, an ancient carbon-rich shard of planetary debris, is to honor natural history itself. The truth is that wonder does not require mythology. It does not require speculation about forgotten universes or erased physics. Wonder is already embedded in the natural, if we learn how to see it. Think of the fossils in our museums. Trilobites pressed into stone, ammonites curled in perfect spirals, petrified wood streaked with minerals. They are not magical. They are ordinary, the expected remnants of life and time. And yet they astonish us. They are fragments that speak across epochs, showing us how different the world once was. 3IATLAS is the same, only on a galactic scale. A fossil not of biology, but of planetary birth. A record not of oceans or forests, but of star systems forming in the chaos of the early Milky Way. To say only a comet is not to diminish it. It is to remind ourselves that even the simplest, most natural things in this universe are extraordinary. That ice and dust, carried across billions of years, can hold within them the memory of creation itself, that a fragment flung outward by chance can survive to tell its story across the gulf of time. So if it is only a comet, then let us listen. Let us measure its orbit, analyze its spectrum, record its passage. Let us place it alongside Oumuamua and Borisov, and recognize that together they are teaching us something profound, that the galaxy is diverse, that planetary birth is universal, that memory is everywhere. Let us marvel not because it is supernatural, but because it is natural, and because the natural, when stretched across billions of years and trillions of miles, becomes indistinguishable from the miraculous. And yet, let us allow ourselves to ask the other question: what if 3IATLAS is not only a comet? What if it is something more, something beyond the natural histories we can easily describe? What if its chemistry, its survival, its improbable journey across billions of years are not only the signatures of interstellar wandering, but the residues of realities erased before our own? The thought is unsettling, but also unavoidable. For each measurement we make its age, its speed, its carbon-heavy composition deepens the sense that this object is not merely unusual but uncanny. There is a difference between strange and haunting. A strange comet bends the rules. A haunting comet feels as though it carries the rules of another place altogether. Consider the possibility that encoded in its dust are laws no longer found in physics. Not only isotopes that differ from what we expect, but isotopes that should not exist in this universe at all. Not only chemical fingerprints from a forgotten star, but fingerprints from a forgotten cosmos. To touch its grains might be to touch the relics of a physics erased at the Big Bang, a physics that wrote its equations in a different grammar, with constants that no longer apply. What would it mean if that were true? It would mean that the Big Bang was not the beginning, but a translation. That everything we know, the galaxies, the stars, the atoms in our blood, was born not from nothing, but from a collapse and rebirth in which most memory was erased. And yet, perhaps not all, perhaps a handful of fragments slipped through the seam. 3IATLAS, in this view, becomes not debris from planetary birth, but debris from universal death. A fossil not of stars, but of existence itself. Pause here. Let your imagination hold that weight. A small body of ice and dust, only a few kilometers wide, drifting into our system for a brief season. And yet, within it, matter that remembers a cosmos older than time as we measure it. Matter that carries in its structure the echo of laws no longer present, like a melody half remembered by an instrument that no longer exists. If we could hold it in our hands, what might we learn? Could it teach us that gravity once curved differently, that light once traveled with another rhythm, that matter itself once danced to a different tune? Human myths have long whispered of relics from before time. In Hindu cosmology, universes rise and fall in cycles, each one following the other like breaths of Brahma. In Norse myth, Ragnarok destroys the world, yet a new one rises from the ashes, carrying traces of the old. In Mayan accounts, suns are born and destroyed in succession, each world inheriting something from the one that came before. Always the theme: erasure, rebirth, memory carried forward. 3IATLAS, seen through this lens, is the scientific echo of those myths, a fragment not only from another star, but from another cycle of reality. Imagine scientists in the future capturing such an object, returning samples to Earth, and discovering in them not only unusual ratios of isotopes, but impossible ones, patterns that cannot be explained by any known stellar nucleosynthesis, elements that do not fit the periodic table as we understand it, laws that hint at constants shifted ever so slightly from our own. To analyze such material would not merely expand our science, it would rupture it. It would show us that our physics is not eternal, but provincial, a set of rules written for this chapter of the cosmos, not for the book entire. Speculation presses further. If laws can change from one universe to another, then perhaps 3IATLAS carries more than memory. Perhaps it carries instruction. Its dust may encode not only what was, but what can be. To study it might be to learn new ways of building, new ways of moving, new ways of thinking. Technology born not from human ingenuity, but from cosmic archaeology. A gift, if we are ready, a puzzle, if we are not. And yet, there is a humbling paradox here. For even if it carries such secrets, it will not stay. It passes once and is gone, fading into the dark with its mysteries intact. Humanity may glimpse it, speculate upon it, measure it with every instrument we have and still fail to decipher its full message. In that sense, it is a teacher not only in knowledge but in humility. It reminds us that some truths are too large for us to hold, that some memories pass by like strangers in the night, leaving us with nothing but questions and wonder. But perhaps that is the message. If 3IATLAS is more than a comet, then its very presence tells us that the universe does not forget entirely, that across collapses and rebirths, across cycles of erasure, fragments endure. That memory is stubborn, survival is possible, and continuity stretches deeper than time. Close your eyes and let that image settle. A comet drifting across the night sky, faint, ancient, inscrutable. It may be nothing more than ice and dust. Or it may be a relic of universes erased, a fossil of laws no longer written, a messenger of realities beyond our own. And in its glow, fleeting and silent, humanity glimpses not only the vastness of space, but the vastness of possibility. For whether we solve it or not, whether we measure it fully or only in fragments, 3IATLAS has already given us something precious. It has given us perspective. It has given us humility. It has given us the chance to ask a question most of us had never thought to ask. What if some things endure beyond universes? What if memory itself is eternal? And maybe, in the end, that is its gift. Not an answer, but a question. Not prophecy, but memory. Not certainty, but wonder. Stone weathers, metal rusts. Even mountains wear down to sand. But ice is different. It is fragile, yes, but it is also a patient archivist. In glaciers here on Earth, ice preserves bubbles of ancient air, pockets of atmosphere trapped tens of thousands of years ago. Scientists drill into polar cores and listen to whispers of climate long vanished, tracing the breath of mammoths, the smoke of ancient fires, the faint rhythms of Earth before writing. Ice holds memory. It holds time in suspension. Now stretch that thought outward. Imagine not tens of thousands of years, but billions. Imagine ice older than our planet, older than our sun, drifting through darkness and still intact. That is what 3IATLAS brings. Its frozen body is a diary of forgotten epochs, a volume in a library whose shelves are longer than galaxies. Each crystal lattice is an entry written in the handwriting of a cosmos we can barely imagine. Each molecule is a sentence describing a chapter of existence older than the continents beneath our feet. The philosophy of ancient ice begins with this recognition, that memory is not always written in words, or even in fossils, but in molecules arranged and preserved. Frozen water, frozen carbon dioxide, frozen traces of nitrogen or methane, they are more than chemistry. They are continuity. They are time made visible. 3IATLAS carries such ice. And when it sublimates under the sun's light, when that halo blooms into a coma, it is like the diary opening, the frozen handwriting finally read aloud into space. What does that diary say? Some of its entries are simple. They say, here is the composition of a system long lost. Here is the ratio of carbon to oxygen, the fingerprint of a chemistry shaped under conditions unlike our own. Here is the isotopic signature of stars that died before Earth existed. But perhaps there are deeper entries too. entries we cannot yet decipher. Because if this comet carries matter from before the sun, it may carry memory from before our universe stabilized, from a time when the laws of physics themselves were still cooling into place. Speculation leans in. What if frozen water is more than a molecule? What if it is a cosmic diary written not only in atoms but in patterns? Some physicists have wondered whether information itself is woven into the structure of matter, that the arrangement of molecules carries echoes of prior states. If so, then the ice of 3IATLAS is not simply frozen chemistry, but frozen memory, a record of processes erased everywhere else, preserved only because it has been locked in darkness for 7 billion years. Pause and hold that image. A shard of ice drifting through interstellar night, unmelting, untouched, a capsule of memory waiting for the right conditions to speak. It is fragile, one close pass to a star, one collision, and it would be erased. But fragility does not cancel endurance. Sometimes the most delicate things, if left undisturbed, last the longest. And so here it is, carrying with it a diary older than Earth, waiting for us to listen. Human cultures have always linked ice with memory. In the Norse myths, the world began in Ginnungagap, a yawning void of ice and fire, where the first beings were born from the melting frost. In Buddhist texts, ice is a metaphor for ignorance that can be melted by insight, releasing clarity. In modern memory, ice is tied to preservation, cryonics, refrigeration, the attempt to hold on to life against the erosion of time. Everywhere, ice is a vessel of continuity. To see 3IATLAS through this lens is to see it not merely as debris, but as philosophy embodied. Consider this. If stone holds memory in form, and wood holds memory in rings, then ice holds memory in purity. It does not change itself. It traps what is around it. It holds air, dust, isotopes, whispers, and when we read it, we are not reading ice, but what ice has carried. 3IATLAS is, in that sense, less an object than a library card, a key to a collection of memories preserved across time. And here, speculation deepens further. What if the cosmos knows this? What if ice is not just a byproduct, but a strategy? What if universes, in their cycling, leave behind ice as a way of carrying forward memory, the way a seed carries forward the memory of a tree? If so, then comets like 3IATLAS are not accidents. They are archives. They are the pages universes leave for each other, frozen diaries drifting between epochs. The philosophy of ancient ice teaches us humility. It teaches us that fragility and endurance are not opposites but partners, that something can be delicate and yet last longer than mountains, that memory does not require intention, only preservation, and that sometimes the universe writes its longest-lasting messages not in stone, but in ice. Close your eyes and picture it. A nucleus, dark and small, surrounded by a halo of sublimating gas, drifting against the stars. Every molecule leaving that surface is a sentence escaping the diary, a word carried into the void. We will not be able to read it all. We may never translate it fully. But to know that it is there, that the diary exists at all, is enough to remind us that memory is everywhere, and that time itself leaves witnesses. And so, 3IATLAS teaches us this philosophy, that to endure is not always to be strong, but sometimes, simply, to be preserved. That ice, more than stone, more than fire, is the true keeper of forgotten worlds. When we look to the night sky, the first things we notice are the stars. They burn, they pulse, they flare, they die in brilliance. Their light defines the tapestry of the heavens, and their life cycles are among the grandest dramas we know. Birth in nebulae, fusion in their cores, collapse into white dwarfs, neutron stars, or black holes. Galaxies themselves collide, merge, cannibalize. shaping new spirals and ellipses in silent dances that take billions of years. And yet, amid all this spectacle, comets endure quiet, small, fragile, drifting without voice. 3I/ATLAS carries no roar of fusion, no burst of gamma rays, no shout of collision. Its message is written in glow alone, the faint reflection of sunlight off ancient ice. While stars proclaim their existence in brilliance, comets whisper. While galaxies thunder through gravity, comets pass in near silence. And maybe that silence is the message, because silence has its own weight. It says, I do not need to burn to endure. I do not need to collide to persist. It says, memory does not require noise. It requires patience. 3I/ATLAS has survived while countless stars have lived and died. Its ice has endured while galaxies have swallowed each other whole. It drifts with no voice but its glow. And yet in that glow is testimony that survival does not require grandeur. Pause and imagine this. Stars exploding, galaxies colliding, supermassive black holes tearing light itself into ribbons. And in the midst of that, a single comet drifts, unaffected, unannounced. Its orbit does not care for spectacle. It carries its memory not in bursts, but in persistence. Its silence is not emptiness, but endurance. Human beings often mistake silence for absence. We fill our own lives with noise, with declarations, with proof that we exist. But sometimes the deepest messages come not in words, not in shouts, but in the quiet persistence of presence. 3I/ATLAS drifts through the void saying nothing, and yet it says everything. I have survived. I remember. I am here. Speculation unfolds. What if silence is the language of the universe itself? Stars speak loudly, but briefly. Their messages are intense, but fleeting. Comets speak softly, but their message lasts. In that sense, 3I/ATLAS may be more than a comet. It may be the embodiment of the cosmos's quieter truth, that what endures is not always what burns brightest, but what listens longest. Cultures across time have understood this. The Tao Te Ching tells us that great truth is often wordless. Indigenous traditions around the world treat silence as a form of wisdom, a way of hearing what the earth or sky might say. Mystics across religions have sought silence, not as emptiness, but as fullness. 3I/ATLAS joins that lineage, a cosmic mystic drifting through space. It does not dazzle with constant brilliance. It does not overwhelm with sound. It simply is, and in that, it teaches us. Think of silence, not as the absence of sound, but as the presence of attention. When you stand under the night sky and notice the faint haze of a comet's coma, you are not hearing a declaration. You are hearing an invitation. The silence of 3I/ATLAS asks you to lean in, to listen differently, to notice not what is shouted, but what is endured. Its message is subtle. Memory is not always spoken aloud. Sometimes memory waits, preserved in ice, revealed only to those who are willing to listen in stillness. There is also a haunting possibility here. Perhaps the silence itself is deliberate, not in the sense of intention, but in the sense of necessity. If 3I/ATLAS carries memory from before our universe, then perhaps silence is the only way it can speak. The physics of its birth may no longer exist. The language it once spoke may no longer be translatable. All that remains is endurance. All that remains is presence. Silence as testimony that some things cannot be explained, only witnessed. And in this way, its silence may be its truest message, a message that says, universes collapse, laws change, stars die, galaxies shatter, but fragments endure. You will not hear it in thunder or in song, but in the quiet persistence of something small, fragile, unbroken. Close your eyes and imagine drifting beside it. No sound, no hum, no vibration. Only darkness, stars in the distance, and a faint halo of light around a core of ancient ice. That is its voice. That is its silence. And in that silence, you hear not emptiness, but eternity. Every story eventually circles back to its beginning. Every mystery, no matter how vast, whispers a question. Where did this come from? With 3IATLAS, that question is both simple and impossible. Did this ancient body form around a star we might still trace, its birthplace glowing somewhere in the galaxy even now? Or was that system long ago torn apart, its star collapsed or devoured, its planets shredded, leaving behind nothing but fragments like this one? Or strangest of all, was 3IATLAS not born within this universe at all, but carried across from a prior cosmos, a relic of laws erased before time began? Astronomers, working within the discipline of observation, ask the first version of the question. They trace back its orbit, refine its trajectory, and ask whether it points toward a cluster of stars, an ancient thick disk region of the Milky Way, a possible system of origin. Perhaps, they wonder, 3IATLAS once circled a faint, metal-poor star 10 billion years ago, before being ejected by gravitational encounters with larger planets. They model such ejections, simulate the scattering of comets, and compare. The language here is cautious, grounded, eccentricity, inclination, velocity, dispersion. In this view, its story begins not in mystery, but in math. But mathematics has limits. Trace its orbit backward far enough, and uncertainties multiply. Gravitational encounters blur the path. Stellar migrations scramble the coordinates. Soon the trail dissolves into fog. The comet becomes untraceable, a wanderer without a clear home. That is when the second version of the question arises. Perhaps its system no longer exists. Perhaps its star was consumed in a collision, its planets scattered, its memory erased except for this one shard. In this sense, 3IATLAS becomes a gravestone, not just an object, but a survivor of a place that is gone. Pause with that thought. You look at a comet glowing faintly in the sky, and you realize this may be the only remnant of a world destroyed before Earth was born. A world whose sun is gone, whose planets are dust, whose history has no other witness. And yet here it is, one small body of ice and dust, carrying forward the memory of its origin, even though the origin itself has vanished. That is not only science, that is elegy. Speculation leans further still. What if neither explanation is enough? What if 3IATLAS is not simply debris from a star system within this galaxy, but something stranger? Its chemistry is unusual, its endurance improbable, its age staggering. Could it be that it was not born under our universe's physics at all? Could it be a relic of a prior cycle of reality, born before the Big Bang rewrote the rules? In that case, the question of origins is not about a star or a system. It is about a universe. This comet would not only be interstellar, it would be intercosmic. Imagine that possibility. When universes collapse, most memory is erased. Stars, galaxies, and even atoms are destroyed. But perhaps a few fragments slip through the seam. Frozen, compact, shielded, they carry across the boundary into the newborn cosmos. They are not many. They are rare, precious, improbable. But if one of them survived, it might look like this: small, ancient, alien in chemistry, unbound by local rules, drifting in silence until a new civilization noticed. 3IATLAS, in this light, is not only a comet, it is a question mark left by another universe in the margins of ours. And so the question of origins fractures into layers. At one level, what star? At another, what system? At another still, what universe? Each layer deeper than the last, each more humbling. Science answers the first tentatively, struggles with the second, and stares into mystery with the third. but all three are part of the comet's story. Consider how this resonates with human traditions. In myth, origins are always layered. A hero may come from a village, but behind that is a lineage, and behind that a god, and behind that a cosmic principle. Every story spirals backward into deeper questions. So it is with 3IATLAS. Its village may be a star, its lineage may be a galactic epoch, its god may be another universe, and behind that, silence. Close your eyes and imagine standing beneath its path, watching its faint trail stretch across the stars. Somewhere, long ago, it began. Perhaps in the cold outskirts of a forgotten system, perhaps in the wreckage of a destroyed world, perhaps in the last breath of a collapsing cosmos. Its glow does not answer. It does not tell us which is true. It only invites us to ask, and to marvel at the fact that we can ask at all. For in the end, the question of origins may be less about answers and more about perspective. To ask where 3IATLAS came from is to be reminded of how much lies beyond us. How much time, how much distance, how many cycles of existence preceded our brief span. Its silence does not frustrate, it humbles. It reminds us that every object, no matter how small, carries a story larger than we can hold. And so, the question of origins remains open. Was it a star, a system, a universe? We may never know. But in the act of asking, in the act of leaning into that silence, we glimpse something profound, that the universe itself is layered with memory, and that even the smallest wanderers carry the weight of beginnings too vast for us to fully trace. If origins ask where, purpose asks why. And perhaps this is the harder question. For it is one thing to say that 3IATLAS was born in the outskirts of a star system, flung into darkness by the gravities of giants. It is another to ask, does it mean anything that it is here? Was it simply chance, blind drift across billions of years that brought it within our sight? Or is there purpose woven into its presence, a purpose not of prophecy, but of memory? Science is cautious with purpose. We are trained to resist teleology, to avoid imagining intent in what may be accident. Yet human beings cannot help but ask. When something ancient and improbable arrives at precisely the moment we can measure it, precisely the moment our telescopes are sensitive enough to notice, we wonder, why now? Why us? Why this messenger at this time in history? Perhaps the answer is mundane. Perhaps 3IATLAS is nothing more than debris, drifting without purpose, carrying nothing but chemistry. A fragment with no mission, no code, no design. And yet even then, purpose emerges not from the comet itself, but from the encounter. For purpose is not always innate. Sometimes it is conferred. In studying 3IATLAS, we give it purpose. We allow it to become a messenger by listening to what it has to say. But suppose we lean into speculation. Suppose we allow ourselves to imagine that its strange chemistry is not random, but patterned. That the unusual depletion of water, the rich abundance of carbon dioxide, the precise isotopic ratios, are not merely environmental accidents but arrangements, patterns written into matter the way words are written into pages. If so, then perhaps its very body is a code, a memory preserved not in language but in molecules. This is not so far-fetched. On Earth, DNA itself is exactly this, matter arranged as memory. 4 simple nucleotides, combined into patterns, store the story of life across billions of years. Our genomes are molecular diaries, holding not only instructions but history. If carbon-based life can do this, why not carbon-based matter on a cosmic scale? Perhaps comets like 3IATLAS are not simply geological fossils, but informational fossils, matter encoded to carry memory across time and space. Imagine what such a code could contain. Perhaps it is as simple as a chemical fingerprint, a preserved record of conditions in a system long gone. Or perhaps it is more ambitious, the physics of another cosmos, written into isotopic arrangements. A library of laws carried forward not by intention but by necessity, because no other form of matter could endure. In this view, 3IATLAS is not only a relic, it is an archive, a frozen hard drive left adrift in interstellar space, waiting to be read by anyone with the patience to learn its language. Speculation deepens. What if this is the very strategy of universes? If cycles of collapse and rebirth occur, then perhaps memory must be carried forward somehow. Not in words, not in signals too fragile, too fleeting, but in matter itself. Comets, then, are more than debris. They are seeds. Not seeds of life necessarily, though that too is possible, but seeds of memory, fragments of one cosmos delivered into another, the code of existence itself, preserved in frozen archives. The question of purpose is not only cosmic, it is also human. What do we choose to do with this visitor? Do we treat it as an object to measure and forget, or as a message to be read? Do we dismiss its chemistry as anomaly, or do we pause to consider whether anomaly is itself the message? Science moves forward by analyzing data, yes. But humanity moves forward by asking, what does this mean? What does this say about us, about our place in a story larger than we imagined? Think of the myths that echo here. The Sumerians spoke of tablets of destiny, inscribed with the laws of the world. The Egyptians imagined the gods writing the order of creation into stone. The Greeks imagined memory as a goddess, Mnemosyne, mother of the muses. In each case, memory was not random. It was written, preserved, carried. Perhaps 3IATLAS is our scientific version of such a myth, an object whose purpose is not prophecy but remembrance. A cosmic tablet inscribed in ice, drifting into our awareness for a brief moment. Close your eyes and imagine holding a fragment of it. Cold, fragile, ancient. You do not see words, you do not hear voices. But within its molecules is a pattern older than the Earth. To read it would require not only chemistry, but imagination. Not only instruments, but philosophy. And perhaps that is the truest purpose of 3IATLAS. Not to deliver an answer, but to provoke the question. To remind us that matter itself can be memory, that silence itself can be meaning. So the question remains, is it simple debris or a carrier of information? The answer may be both. It may be debris, but debris that encodes the conditions of its birth. It may be a carrier, but not of intention of necessity. Its purpose may not be to say something, but simply to be something that endures. And in that endurance, it becomes message. In the end, purpose is not always discovered. Sometimes it is created. By watching, by wondering, by listening to this comet, we create purpose. We allow it to become more than dust and ice. We allow it to become memory. And perhaps that is the deepest message of all, that the cosmos provides fragments, and humanity provides meaning. Together, the two create purpose. If 3IATLAS teaches us purpose through endurance, then to deepen that lesson we must set it beside others. For meaning often emerges in contrast. One comet alone is mystery. A comet compared with its kin becomes revelation. In the solar system, we have our own fossils of time, asteroids, comets, and planetary remnants that preserve the history of our local neighborhood. Among these, Jupiter's Trojan asteroids stand as archives of the early solar system, locked in gravitational balance for billions of years. The Trojans are survivors of our own planetary birth. Trapped in the Lagrange points of Jupiter, they circle the Sun in step with the giant, preserved by the subtle equilibrium of gravity. Their surfaces hold clues to the conditions of the protoplanetary disk that birthed Earth, Mars, and the rest. Their chemistry, their distribution, even their colors are stories of our beginnings. To study them is to study the diary of the solar system itself, preserved not in ice but in stone, Now set beside them an interstellar comet like 3I-ATLAS. The Trojans preserve local memory. Atlas preserves galactic memory. One speaks of how our sun and planets formed, the other whispers of how other stars, older than ours, shaped their systems. One belongs to our family, bound by gravity, circling with us across ages. The other is a wanderer, unbound, untethered, a stranger passing briefly through. To place them side by side is to expand perspective from the parochial to the cosmic. But what if we expand further still? If Trojans are fossils of the solar system and interstellar comets are fossils of the galaxy, then what of 3I-ATLAS specifically? Its age, its chemistry, its improbable endurance suggest something larger still. It may not simply be galactic memory. It may be multiversal memory, a relic not of this cycle of physics alone, but of prior cycles erased. Where Trojans speak of planetary formation, Atlas may speak of cosmic rebirth. Pause and let that contrast settle in your mind. A Trojan asteroid and 3I-ATLAS are both rocks, both remnants, both fragments of creation. Yet one remembers 4.5 billion years, the other remembers 7 billion. One recalls the birth of Earth, the other recalls a time when Earth did not yet exist, when even our sun was absent. To study them together is to glimpse the layers of memory the cosmos holds, each deeper, each older, each humbling. Imagine walking through a library of fossils. In one room, you see trilobites, ammonites, the preserved shells of creatures long extinct. In the next, you see ancient trees, petrified wood, rings frozen in mineral. And then, deeper still, you see fragments of the first rocks that cooled on Earth, carrying whispers of a time before life. Each room expands your sense of history. Now imagine a final chamber, holding a shard not of Earth, not of the solar system, not even of this universe. That shard is 3I-ATLAS. It belongs to the deepest archive of all. Speculation flows. Perhaps the cosmos has always preserved its memory in layers. Local fossils for local stories, galactic fossils for stellar histories, and rare intercosmic fossils for the stories of universes themselves. Each layer builds upon the last, each shard reminding us that time is not uniform but stratified, like rock pressed into sediment, like rings in a tree. 3I-ATLAS, in this sense, may be the deepest layer yet revealed. And if that is true, then the act of comparison is itself revelation, for it shows us that memory is everywhere. It shows us that every scale of existence preserves its record planets, systems, galaxies, even universes. To compare 3I-ATLAS to Trojans is to see that what we take as ordinary is extraordinary in context. A local asteroid becomes profound when placed beside an interstellar wanderer. And an interstellar wanderer becomes more profound still when we realize it may be a relic of realities erased. Close your eyes and envision it. Jupiter's Trojans, countless rocks circling in silence, remembering the birth of our system. 3I-ATLAS, a single visitor, remembering something larger, something older. Together they form a dialogue of fossils, each carrying memory, each inviting us to listen. One whispers of the local, one whispers of the infinite. And perhaps this is the truest comparison, that by studying both, humanity learns its own place in the archive. We are not only readers of these fossils, we are fossils in the making. Our civilizations, our oceans, our continents will one day be memory too. And in that recognition lies the deepest kinship of all, between ourselves, the Trojans, and 3I-ATLAS. We are all fragments. We are all memory. We are all layers in the cosmic archive. If 3I-ATLAS stands as a fossil of forgotten time, then what lessons does it hold for the planets? We cannot see the countless exoplanets orbiting distant suns, some faintly glimpsed in our telescopes. others forever hidden in the glare of their stars. The arrival of this interstellar visitor reminds us that to understand exoplanets, we must think not only in terms of direct observation, but also in terms of fragments, fossils, and echoes. For comets are the loose pages of planetary books, torn free and carried across space. When astronomers detect an exoplanet, they usually do so indirectly. A star dims as the planet passes before it. A wobble reveals the pull of unseen mass. Occasionally, the faint glow of an atmosphere is teased from the glare. These are fragile glimpses, outlines of worlds we cannot touch. But 3IATLAS offers something else entirely. It is physical. It is tangible. It is a piece of an alien planetary system delivered into our hands. Its age bridges stars we cannot see. 7 billion years old, it remembers a time when many of the stars we now observe were still forming, and many more have since died. To hold 3IATLAS in thought is to hold continuity between epochs of the galaxy. Its chemistry is not only an echo of one system but a clue to many. For if one star gave rise to carbon-rich comets, then others may have done the same. By studying this fragment, we extend our imagination beyond visible planets to invisible histories, and here speculation blooms. Perhaps even alien civilizations once walked beneath the stars that birthed 3IATLAS. If this comet is older than Earth, then any worlds it once circled might have had time for life, for growth, for rise and fall, long before our sun ignited. We do not know. We cannot know. But the possibility is staggering. This fragment could be the last surviving witness of worlds erased before our own world began. Not only planets lost, but perhaps cultures, perhaps languages, perhaps stories. If so, then its survival is not only geological but civilizational. It carries not only the memory of chemistry, but the ghost of civilizations we will never meet. Pause and imagine this. An ancient planet orbiting a faint star, oceans lapping against alien shores. A people, whether biological, mechanical, or something else entirely, looks up and sees comets tracing the sky. Among them, one fragment is pulled outward, ejected by a giant planet's gravity. It drifts away, unseen, unnoticed, as the civilization rises and falls. Millennia later, their sun dies, their world is gone, their memory erased except for that single comet still drifting. And billions of years later, it arrives here, glowing faintly in our sky. What we see as chemistry may also be the last whisper of a story we cannot read. Science grounds us. It tells us that interstellar comets are inevitable, that every planetary system ejects debris. But philosophy expands us. It reminds us that debris may not only be geological, it may also be cultural. Civilizations, like comets, can be ejected from time. They can rise and fall, leaving only fragments behind. 3IATLAS, in this light, is both comet and metaphor. It tells us that what is lost is not always entirely gone, that sometimes fragments endure longer than worlds. In terms of exoplanets, the lesson is profound. We cannot visit them all. We cannot even see most of them, but we can study their fragments. Each interstellar comet is an emissary, carrying the memory of a system across gulfs of space. By learning to read them, by learning the language of isotopes, of volatiles, of ancient ice, we can reconstruct the histories of worlds we will never see. In this sense, interstellar comets are not only fossils, they are textbooks drifting through the galaxy, waiting for us to open them. Speculation deepens. If comets can carry chemistry, can they also carry life? The panspermia hypothesis suggests so, that life's ingredients, or even microbes themselves, might travel within comets. If this is true, then perhaps 3IATLAS is more than a fossil of a system. Perhaps it is a seed of a world, not only a record of a planet that was, but a carrier of the potential for planets yet to be. If so, then the lessons for exoplanets are even greater, that life may not be confined to its place of birth, but may wander, as comets wander, across systems and epochs. Imagine, then, the galaxy not only as a collection of stars, but as a conversation among them. Each star births worlds. Each world sheds comets. Each comet carries chemistry, memory, perhaps even life, across the gulfs. And so the galaxy becomes not a set of isolated systems, but an ecosystem of exchange, connected by these wandering fragments. To study 3IATLAS is to glimpse that larger ecology, that hidden web of memory and possibility. And yet, the lesson may be humbler still. Perhaps 3IATLAS teaches us that survival is possible beyond context, that even when systems are destroyed, even when stars collapse, fragments endure. Exoplanets may come and go, civilizations may rise and vanish, but memory persists in debris. In that sense, every interstellar comet is a reassurance that the universe does not forget entirely, that even when worlds fall silent, something carries forward. Close your eyes and picture it, a faint trail of light across the night sky, a fragment from a world you will never see, a world that may no longer exist, and yet, in its silence, it speaks. It tells us that exoplanets are not distant in every sense. They leave traces. They send emissaries. They participate in a conversation older than humanity, older than Earth, older than the Sun. This is the lesson of 3IATLAS for exoplanets, that the stories of distant worlds are not beyond us. They arrive, piece by piece, in fragments of ice and dust. They remind us that the galaxy is not only vast but connected. That memory is not only local but galactic, and perhaps, in rare cases, even multiversal. 3IATLAS leaves us with more questions than answers, and maybe that is the point. For what is it, truly? A comet, yes, an icy fragment wandering across the stars, but also a fossil carrying chemistry older than Earth. A messenger, reminding us that the cosmos is layered with memory, and perhaps, most hauntingly, a piece of something greater than we can yet name. Is it debris flung outward from a forgotten galaxy, the natural relic of stars long dead? Or is it something stranger, an echo from a cosmos before ours, a survivor of a universe erased and reborn? Its silence offers no certainty. It only presses the question deeper into us, as if the asking itself is part of its gift. And so it drifts on, away from the sun, its coma fading, its glow thinning, until it becomes invisible once more, another ember swallowed by the dark. But in its wake, it trails dust, not just the dust of ice and carbon, but the dust of memory itself, a trail stretching back across billions of years, across the lifetimes of galaxies, perhaps across the lifetimes of universes. Close your eyes one last time and picture it receding, silent, alone, carrying its message into night. Somewhere, far beyond our reach, it will continue, drifting endlessly, and in that drifting, it will remember. It will remember stars we cannot see, worlds we will never walk, and perhaps even a universe that no longer exists. That is its legacy. That is its haunting gift, to remind us that even in silence, memory endures. To remind us that we, too, are fragments passing briefly through, and to leave us with a question that lingers long after the light has gone. Was 3IATLAS only a comet, or was it an echo of a forgotten cosmos?